Well, hello and welcome to another Fix It video with me, Chaz Large, and I've got something different on the bench today. This is a device, an Eiger Night Guard night light and torch, and sent to me because it has stopped working. And basically it's a two-piece device. You plug this into the mains, and through induction charging, this charges an internal lithium battery, and it produces a night light, so it's on all the time, but it comes on when the PIR sensor in the middle here detects movement, so it's sort of saving energy, I suppose, whilst it's not moving. But you can also take it off and press the button on the side and you should get a torch out the front. And it was working, and now it's not. So diagnosis, where do we start? Well, what I decided to do first off is to see whether the base unit was actually taking any current. I didn't particularly want to take it apart too much first, so basically I've got a socket where I can put a current meter in series with it, plugged it in and saw that it was drawing 300 odd milliamps, and then when I unplugged this the current disappeared, so it was definitely drawing current. So I'm gonna say at the moment I think this is okay. The chances are it's probably the battery in here which has failed. So I'm going to start by taking this part apart, and on the back there's four little rubber bungs, I suppose you would call them. So if we can get a little screwdriver in there, they don't appear to be stuck in. I took one out earlier just to test before I started filming, and they just pop out. So we can take those out, and obviously we can see what's on the inside, and we can check to see whether the battery has got any kind of voltage on it. If the battery's got some voltage to it, it could well be the electronics. If we've got a charge on the battery, then there's a good chance that it's the electronics, but if it's not the electronics, it could be the battery, so one or the other. This should now come apart fairly easily. I should be able to run my thumbnail around the edge. Great, it's got no plastic clips. So there we are. Inside we can see we've got this is the induction coil, and that's obviously what's picking up the AC. That's our PIR sensor, power circuit, and there's the battery. And the battery, I'm not sure whether that's got a bulge in it or not. It feels a bit, doesn't feel flat. So let's just have a little look and see whether we've got any voltage on it. Yeah, okay, just a little bit of re-maneuvering of things. Should be able to get a little bit more access to this battery. Trace the wrong wires, and it's only got 16 millivolts on there. Okay, so that being the case, let's get an extension so we can see all this on the bench. What we can do is we can put this here, and we can plug the charger in, pop that into there, turn that socket on. We have mains, so let's now see the meter over here. Now let's see if we've got any voltage getting to the battery, holding the charger in place. There doesn't seem to be any voltage getting to that battery. Still down to 1 millivolt. So let's see if we've got any AC voltage, because that's going to be AC coming in that coil there. That's going to be coming in there. Let's see what. And half a volt? Yeah, it's got to be, should be more than that, surely. Nothing. Still no volts coming in that coil. So I think what we'll do is we'll have a look and check out the circuitry in here and see if there's any voltage being generated within this device. So I'm going to move the camera down here now a little bit closer so we can have a look in here. Let's put those out of the way for a minute and have a look. Just make sure the camera is in the right place. There we go, and we'll just do a quick focus. So this AC part of it has got 4 little bungs as per the receiver, so we'll just ease those out. So hopefully that will just ease apart, and maybe a little lug or something. Being a little bit tough on this corner. Maybe something in there is catching it. There's no clips or anything. So now there is a magnet there. I think that's a magnet. So that magnet there, is that, looking in here, perhaps that, yeah, so perhaps that metal plate there is what holds it in place. There's no switch or sensor or whatever, so now that's useful that the AC side of things is all nicely insulated, but that looks like it's got warm. There's a capacitor in there. Let's bring the camera in a little bit closer so we can see it in more detail. Alright, so looking in here, I have to put my specs on so I can see a bit more clearly. Aha! Now that looks to me like a resistor which looks like it's burnt out. So I would guess that is probably where our fault lies, wouldn't you? But that's burnt out. Now it could be that some of these components may have failed and caused that to go dead. Or it may just be that that resistor is just not man enough for the job. A little tantalum bead there. 4 diodes, presumably a bridge rectifier. So if we go into resistance mode on the meter, bring the meter here, move that across and you can see what we're doing. So let's just check and see. Let's just, meter is reading ohms. Let's just before we do that, actually what we'll do is we'll just put the meter on DC, and just in case there's a charge in this capacitor, 100 millivolts, so not a lot to worry about. Go back to ohms. Let's just put it on continuity. That was okay, that was okay, that was okay. So they're not burnt, they're not short. And this little resistor here, whatever it is, seems to be open. There's no resistance to that at all. Let's go back to ordinary ohms. It's in the mega ohm range. So I think that may well be the cause of it. So let's see if we can take this circuit out and work out what this is. Now, I would have thought it had been screwed in, but it seems to be all sort of like held in with double-sided tape, like a sticky pad down there. So let's see if the coil will just ease up out of it. Yeah, that looks to be loose. So it's just this circuit here, which is undoubtedly, if we put a lever out, we can sort of work out what the circuit is doing. So I think what I'm going to have to do is take a quick snapshot of this and see if we can work out how this circuit works. But I'm pretty sure what we've got is AC going in there, a couple of filter capacitors and a coil, yeah, F1 filter, and that goes into the bridge rectifier. Two diodes there. That's the DC side of things. And this presumably is a little transistor which is switching to generate an AC frequency coming out of there, which it won't do if that resistor R4 is burnt out. Trouble is, it's gone completely. There's no way of determining what value that should be. R3 is 1 mega ohm. So I think I'm just going to see if I can quickly draw out the circuit and work out what is going on, and what, if we can try and work out what value of that resistor should be. Couldn't find a manufacturer's spec or anything like that, but I did a lot of searching on the internet and found a couple of forums where this sort of product had been discussed, and one video that showed that the customer had got a faulty one, but that's about all it said. But anyway, I managed to sort of work out what the circuit was, and it's basically AC into a filter circuit, into a bridge rectifier, out of the bridge rectifier, a big capacitor there, 400 volt capacitor, into this little circuit which consists of a coil. Excuse that diagram there is not a gate, a digital gate, it's a transistor. I just drew it like that as a representation of the top of the actual transistor, because I sort of sketched it out as per the layout. So anyway, we've got a coil that comes down to the collector, and then from the collector to the emitter there's a capacitor, emitter, down through the resistor that had burnt out, R4, and a capacitor across there. And it turns out that that resistor is 2.4K, and we've got a capacitor here to the base and a resistor to the base. So basically what this is basically a very crude oscillator. Now on the forums that I've looked at, quite a few people have said the transistor goes faulty. That causes the resistor to burn out, because the current that flows down through the coil, through the transistor, down into the resistor is quite not necessarily high current, but high voltage. The transistor is rated at 400 volts. It's actually an MJE 13007, and quite a few people have said, well, the transistor goes faulty. Now I've taken the transistor out and checked it, and the transistor checks fine, as do the capacitors and the resistors. So it just seems that this poor little resistor here just basically said, I've had enough, and I'm going to give up. And that seems to be a very common failure of this particular circuit. So having a look through my drawers of resistors, I couldn't find a 2.4k resistor, so especially one that was a bit more meaty than this one that had burnt out, this particular one here. So what I've managed to find is two small wire wound resistors, which you can see here, that I've put into series. Let me just focus that. So I've put two resistors, 1.12k and 1.8k in series, so it's about 0.5k above the value that it should be, but that shouldn't be too bad. But because the resistor originally sat there and the space is limited in this circuit, what I've done is I've mounted the resistors like that, taken this capacitor off which was mounted on the top and put it on the underside, and then managed to sort of sit it all into the case so I can see that it fits. So at the moment that's as far as I've gone. So if you want to see a big bang, this is the point when, if anything's going to happen, it will go big bang. So I'm going to stand well back and plug this in. So here we go, 3, 2, 1. Right, no smoke. Okay, well, I'm not going to put my meter anywhere near there for the minute because we've got a large capacitor. Let's just make sure that the actual bridge rectifier circuit is working. I just need to put my better specs on so I can actually see where I'm probing. On there, 260 volts, so the bridge rectifier is working. So it's dropping quite rapidly, so it's discharging through parts of the circuit, obviously. So we won't know if that is actually working properly until we get it back into its case. Let's see if we can do that. Let's take the top part of the case, that sits on there. It's got a little locating lug for the coil. That sits on there, and then that sits on there, and basically it's held together by the screws. Let's get the screws. In other parts of the world, this device is known as a sunbeam night light or sunbeam torch light. This one's brand is an Eiger, but they all seem to have exactly the same circuit, maybe slightly differently laid out on the circuit board. So just nip those up. Okay, and then we'll pop that into the socket. Round the right way. Let's pop this part of it into its cradle. Let's plug it in. Let's get our meter. On DC volts. And battery terminals are that one. And that one. .3 volts. Yay! It seems to be working. So we are charging up the battery. Wunderbar. I think we fixed it. Right, so what I'll do is I'll just pop that back together like that for now, and I'll leave it to charge. Okay, it's been a couple of hours and I checked this and it was charging quite happily, so I've put all the screws back in the bottom unit, put the little rubber bungs back on. It is getting a bit warm, but not excessively so. I wouldn't have thought this was getting like dangerously hot, but it is getting hot. So, you know, maybe that resistor may burn itself out again at some stage, I don't know. But, you know, I can hold my hand on the hot spot, fingers on there, and it's not like it's going to burn through my fingers. So I think we're pretty safe with those resistors. Interesting the way that this operates. Whilst it's in the holder, you've got a button on here. If you press the button, the backlight comes on there, so that's your night light. and if you press it, it goes off again. If you take it off, it automatically turns the night light on, and you can press the button and it switches to torch mode. So you've got a torch to use, and you press it again and it turns off. On the side you've got, let's have a look at that, dawn to dusk off and on. So if that's turned on, what should happen then is when it's in the tray, when it goes dark, let's turn that off. When it goes dark, it should come on by itself. Now there's a lot of light in this room, which probably will stop it from activating. There may also be sort of a bit of a timer circuit in that part of the PIR detector and so on, or the dawn to dusk sensor. So I don't think that's, I'm going to say that that's working 100%. I don't know, but I'm going to give it back to the customer and say, if that bit's still not working properly, then we'll have another look. But effectively, as far as I'm concerned, that should be working as well as it did, because there was no fault with this top bit. All the fault was with the base bit. So that's it. I hope you've enjoyed this little journey into the world of rechargeable night lights using induction charging. I've learned a lot. Got a nice little circuit for the thing. Thanks very much for watching. Take care now. Bye bye.